Hi, good morning. In today's video, I'm going to analyze this function graphically. Last time we saw polynomial functions. Today's video are going to do this type of a function which contains square root. Okay. The first thing we should do, we are going to determine the domain range of this function. So for all x real number x plus 1 superior to 0, and also square root of x plus 1 minus 1 has to be different than 0 because it's located at the denominator. Okay, so always denominator has to be not equal to 0. Okay, now since we have this one different than 0, so that's mean x different than 0. So the domain range of this one, x so that's mean x belongs to this interval minus 1, 0. 0 is not included. Okay, union 0 plus infinity. Okay, this is the domain range of this one. Now let's move on to the next step. Okay, limit after point 0 and plus infinity. 0, we have the limit from left hand side and the limit from right hand side because we have two intervals. Okay, 0 is not known number, is unknown number. Okay, because it's out of domain range, 0 not included. So let's calculate the output of minus 1 because we don't have any problem with minus 1. We don't need the limit here because we can plug into our function. Is given as output point without any problem, without any restriction. Okay, so f of minus 1 equal from the left hand side. That's mean you are in the negative number but very small. Okay, so that's mean minus 0.00001. For example, you have very small number but it's negative. Plus 1 is going to give you 0.0 okay, 9 for example, and 9999. This is the way this number is written. Okay, so square of this one 0.0999 minus 1. This one it will be the smaller than 1. Okay, because you still is not a 1 yet. Okay, so that's mean this number 0.999 minus 1, which is minus 0.00001. Okay, so this one is approaching to 0 but with a negative number. What does this mean? When you put any number like any number at the top, like numerator over 0.000 with a negative sign, that means going to minus infinity. Okay, so this one is going to the minus infinity. This is our limit. Okay, so let's move on to the limit of f of x. X is approaching to 0 but from the right hand side. Okay, so the limit square root of x plus 1 over square root of x plus 1 minus 1. X is approaching to 0 from the right hand side. It will be the same thing, but from the right hand side. When you plug in the same thing, when you plug the 0 from the right hand side in this fraction, that means give you 1.1.000 minus 1, which is a positive number, but it's still 0.000, right? So this one, we put 0 at the top, so 1 plus 1 is 2, 2 over 0 from right hand side, 0 plus, this means is giving you plus infinity, okay? Plus infinity. So let's move on to calculate the limit at the point plus infinity, okay? The limit f of x is approaching to plus infinity. When you plug plus infinity into this function, is giving you plus infinity over plus infinity, which is an indeterminate form, okay? So this one giving you plus infinity over plus infinity. So this is indeterminate form. So we are going to transfer this form into the new expression where we can find the limit, okay? To derivative function, okay? To calculate the derivative function. So in order to calculate derivative function, okay, we have to make sure your function continues and derivative on interval, okay, that you have. So since we have square root of x plus 1, which is this one, is located at numerator, continuous and derivative function on minus 1 plus infinity. The second function, which is located at denominator, which is square root of x plus 1 minus 1, continuous and derivative function on minus 1 plus infinity. So this means our fraction, which is equal to f of x, continuous and derivative function on this interval that I have, okay? So now I'm allowed to calculate derivative function of this one, okay? So if you are going to derivate the fraction f over j equal f prime multiplied by g minus g prime multiplied by f over g square, okay? I'm going to calculate the derivative function. We have this fraction rule, f over g prime equal f prime multiplied by g minus g prime multiplied by f over g square, okay? So that's what I'm plugging here now. So now f prime of x equals square root of x plus 1 derivative multiplied by square root of x plus 1 minus 1 minus square root of x plus 1 minus 1 multiplied by this one square root, this is prime, square root of x plus 1 plus 1, okay? So f prime of x, don't forget square root of x plus 1 minus 1 square, okay? So f prime over x, what's the derivative function of this one? 1 over 2 times square x plus 1 multiplied by this one, which is square root of x plus 1 minus 1 minus this one, the same thing, 1 over 2 times square x plus 1 multiplied by square root of x plus 1, right? Over square root of x plus 1 minus 1 square. Let's put 1 over 2 outside as a multiplier. and put the whole thing 1 over 2, put 1 over 2, 1 over square root x plus 1 outside as a multiplier. So this one is giving us square root of x plus 1 minus 1 minus this one minus square root of x plus 1 minus 1. This one will be cancelled out, x plus 1 minus 1. So this one minus 1, which is minus 2 multiplied by 1, 1 over 2, which is minus 1. So our fraction becomes minus 1 multiplied by this one. So equal the whole thing minus 1 over square root x plus 1 multiplied by square root of x plus 1 minus 1. So I'm running out of the room. I take this one at the top and continue with our problem. Now my f prime of x is ready. Now I'm moving on to do the variation table, where I can see the sign of f prime of x and the direction of the function as well. Okay, let's do the table. This is first line is representing the x. Okay, that's mean input. We have this interval. We have, as we mentioned before, we have minus 1, we have 0, 0, we have plus infinity. Okay, so now we have f prime of x, we have f of x here. Now f prime of x equal minus 1 over square root of x plus 1 multiplied by square root of x plus 1 minus 1 square. So we have the denominator is positive, numerator is negative. That's mean our function, this one is a negative function, f prime. Okay, this one is inferior than 0. So since f prime of x equal minus 1 over square root of x plus 1 multiplied by square root of x plus 1 minus 1 square, so that's mean we have numerator is negative, denominator is positive. That's mean our function is f prime of x is negative. Okay, so strictly inferior than 0. So this means determine the direction of the function. So since we have f prime of x is negative, so our function f of x is decreasing. Okay, it's decreasing on both intervals. Okay, minus 1, 0, 0 to plus infinity. So the output of minus 1 is minus 1. So the limit of 0 at the 0 point from the left hand side, it was minus infinity. This will be already calculated. So the limit of f of x at the point 0, the 0 is approaching from right hand side. So that's mean plus infinity to 1, because the limit of f of x is approaching to infinity is 1. Okay, now I'm done with the sign of the f of x. Now I know the direction of the function. So now I'm moving on to the graph where I put my function. Okay, this is the graph. Okay, minus 1, minus 1. This is 1, 1. This is x axis, y axis. This is the output minus 1, input minus 1. The output is minus 1 as well, which is this one, on vertical axis. This is the point where the function passes by. Also 1 minus 1 is one of the points where the function passes by. Okay, so I have minus 1 as the input, I have minus 1 as well as the output. So this is 0, our function starts coming down from -1 to -infinity, down this way. Okay, from 0 the function is coming this way as well, but the function get to the number 1 like here. Okay, this is my function. Now I get the whole thing done, so the function is in graph. So thank you for watching. I will see you in next video. Bye.